huge chunk of ice has broken away from the Arctic's largest remaining ice shelf.
Germany, 42 degrees, continuing to rise.
5 named storms. This has only happened once since...
More than 8,000 fires were reported in this part of the Amazon.
People don't really understand it until you actually see it coming at you in a wall of flame.
As the global average temperature rises, extreme weather events are becoming more and more prominent. This is the direct result of human activities, and in particular, the use of fossil fuels and the resulting increase in greenhouse gases in the atmosphere. While having avoided this problem for a long time, the global community finally recognized the dangers of climate change and in 2015 came to an agreement to limit the increase in the global average temperature. The global community, with the exception of a few countries, committed to limit the increase to strictly below 2 degrees Celsius and work towards keeping it close to 1.5 degrees above pre-industrial levels. And while this target temperature level does not prevent further increase in extreme weather events, it is a compromise between maintaining economic stability and avoiding irreversible damage to the environment. There is no question that the Paris Agreement is a positive sign. However, it might be too little too late, as we are already 1 degree above pre-industrial temperature levels, and if the world continues to warm at the same rate, we would reach the 1.5 degree level at around 2040. Thus, if there's any time left for action, it's running out fast. This is especially troubling given that fossil fuels currently cover about 80% of the global energy needs, and all of that has to be phased out while at the same time the world's population and energy demand is growing every year. But it gets worse. Even if we somehow did manage to phase out all of the coal, oil and natural gas before 2040 through some massive global energy transition in power generation, transportation, manufacturing and agriculture, with all countries working together hand in hand, it would still not be enough. But then, how are all these scientists even predicting we can stop the rate of global warming if even achieving the impossible won't help? Well, the short answer is magic. Sorry, just kidding. I mean technology. More precisely, industrial-scale technological solutions that are not only carbon neutral, but carbon negative. However, the weird thing about this method is that for it to be truly successful, we would have to start cutting down and burning trees. A lot of trees. Okay, what exactly is a carbon negative technology? Well, simply put, it's a technology that's able to extract CO2 from the air and effectively take it out of the Earth's carbon cycle. Kind of like trees and vegetation. But while trees release the carbon they absorbed when they die, this technology would lock it away for good. What I'm referring to is carbon capture and storage, or CCS for short. CCS could be deployed in the open and just filter the air, but perhaps it makes more sense to combine it with power plants or industrial operations where the concentration of CO2 is larger. If we look at power generation, for example, CCS could be combined with power plants that run on coal or natural gas and capture the resulting CO2. That, however, would not result in a reduction of the existing CO2 in the air. This is because the CO2 from fossil fuels is new to the carbon cycle, and capturing it does nothing to reduce the existing levels in the air. If, however, we were to combine CCS with biomass power, that would take CO2 that was captured from the air by trees and vegetation and take it out of circulation. Thus, the more biomass we burn with CCS, the more CO2 we will be able to take out of the air. While this concept looks good on paper and is realistically the best thing that scientists could come up with to make their projections work, there are some issues. Well, there are actually a lot of issues, but we'll just focus on the main ones here. First of all, CCS is still in its experimental stages. Its deployment is quite limited, and estimates suggest it would also be quite costly to implement, with price per ton of CO2 ranging from $60 to $250. Also, in order to have a significant impact on existing CO2 levels in the atmosphere, we would need to burn a lot of biomass. Estimates suggest that we would need to grow enough trees or monocultures to cover the area the size of India. And that's at the very least. That's a lot of arable land, which would otherwise be used for growing crops, which in turn would likely result in food shortages. We would also need to use a lot of water for irrigation, putting great pressure on water resources. Large amounts of fertilizer would also be needed to speed up production, which ironically would likely result in greater greenhouse emissions and have other negative ecological impact. Lastly, the locations where the large volumes of biomass can be grown and CO2 can be stored do not necessarily overlap. That means that we would either have to build large infrastructure to transport the CO2 or transport the biomass closer to the storage area. And then there's the question of how permanent would the CO2 storage really be? Even if we were to solve for all of the above, we would still have to develop and implement CCS and biomass energy at a staggering pace if we were to keep the global temperature within the target levels. But there's perhaps an even greater argument to be made against bioenergy and carbon capture and storage. And that is that it offers a technological solution to climate change, which in effect is an excuse for humanity to continue with its current unsustainable usage of energy, production and consumption. In reality, CCS is by no means a magic bullet against climate change, and there would likely be a great cost to be paid if we were to rely on such a solution. Perhaps the one thing we can say for certain is that the climate will get a lot worse before and maybe if it gets any better.